I don't think I've got anything weird to do this time. I'm just going to do the notes. And hopefully you can deal with that. The last thing's about inequalities. Just remember, inequalities means literally not equal to. So we're talking about things for the most part, except for one example, where things do not equal to each other. And we're looking for two different things, which we'll see. First thing we're going to do is what's called the Pythagorean inequality. So that's going to use Pythagorean theorem, right? Which we said is a squared plus b squared equals c squared. And we said that only works with right triangles. So if a squared plus b squared equals c squared, then it's a right triangle, because that's the only thing that'll work. Now, something that could happen is I can give you three sides of a triangle, and you'll get a squared plus b squared, and you'll see that c squared is larger. If that is true, it's an obtuse triangle. The way I figure that, the way I visualize that in my head, is that if we have a right triangle, boom, 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 right? And we know a squared plus b squared is c squared. But when we extend that right triangle, when we make c squared bigger, right? So we're like, hey, actually we want c squared to be bigger. Well, what happens? We have to make a go this way, and now it's turned into an obtuse triangle. So if c squared's bigger, and that's the thing you've got to get in your brain. C squared's bigger, bigger means obtuse. Then obviously the opposite will be true, but we'll do an example. I'll say, hey, what type of triangle is this? And you'll be like, hey, I got to use that Pythagorean inequality that Galloway was talking about. So let's do 7 squared plus 6 squared and compare it to 12 squared, 144. We add those together. 85, 144 is greater than 85, so it's an obtuse triangle. So the opposite can also be true. If c squared is smaller than a squared plus b squared, it's acute. And it's sort of the same thing. A squared plus b squared, and compared to c squared, 25 plus 25 is 50. So 25 is smaller than 50, so it's acute. You got a nice little acute triangle over there. And so that's when I ask you what type of triangle. This is the big thing that people mix up, is this and the next part. If I ask you what type, you're doing a squared, b squared, and c squared and comparing. If I'm asking you to do the normal triangle inequality, I'm going to ask the question literally, can these sides make a triangle? So if I have a stick that's 3 feet, 2 feet, and 10 feet, can I even make a triangle out of that? And I think this one's a little more obvious, I'd hope, for you all. But if you think about it, let's say I have a 10-foot stick here, and then I have a little 3-foot stick here, bloop, and then a little 2-foot stick here, bloop. There's no way I can make a triangle out of this. Like, they won't reach, right? The answer is no. But how about if I have a 3-foot, a 7-foot, and a 10-foot? So almost the same as this one, but instead, this last one is 7 feet long instead of 2 feet. Oh my gosh. So, let's actually make these look a little... I wish I could... Well, maybe this will work. I don't know. We were doing green, right? 10 foot, right? That was my phone. I bet my parents landed. Nope. Dang it. That's just junk. So, 10 feet long. This one's 3 feet long. Oh, wow. You can't really see that at all. And this one's 7 foot long. So, it's exactly even. So, let's say I have one really long triangle here, line here that's 7, and they exactly match up on top. So because 3 plus 7 is 10, right? As soon as I try to make a triangle out of it, I can't just have two lines on top of each other. I've got to try to triangle it. What's going to happen to my fingers? Blah, 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 blah. There's a gap. And you got to make that sound when you get closer to the camera. That also cannot make a triangle just because, oh my gosh, keep forgetting that my stupid face blocks that part of the thing. I wish I could move this thing to the side. It won't center. It always centers it though. So a 3-foot, a 2-foot, and a 10-foot is a no because it won't reach. A 3-foot, a 7-foot, and a 10-foot side is also a no because as soon as you try to make a triangle out of it, there's going to be that little gap like there was between our fingers. So the rule you've got to know is that the two smaller sides must add to be bigger than the last side. Always, always, always. So all you've got to do when I ask, can these sides make a triangle, is add the two small sides. And if they're bigger than the third side, the answer is yes. If they're not bigger, which means that's smaller or equal to, the answer is no. You're like, hey, look, 5, 8, and 12. 5 plus 8 is 13. 13 is bigger than 12. Yes. 7, 9, and 27. 7 plus 9 is 26. 26 is smaller than 27. The answer is no. The last thing that I might ask you to do is order from least to greatest. Okay. And this is kind of, I'm not asking you to order the angles on this one. I want you to tell me what side is the smallest and then the greatest. Okay. Boop, boop, boop. The smallest side is AC, then BC, then AB. But why? And then on this one, I can give you the sides, and I might ask you what angles are smallest from least to greatest. And the thing you've got to realize, that what I haven't shown you yet, is that bigger angles mean bigger opposite sides and vice versa. So what that means is 22? Yeah, 22. You look, if I ask you for the least to greatest, you're literally going to look for the smallest angle. And then you're going to go across. Like 57 is the smallest. Boom. That opposite side is the smallest. AC. Look for the next smallest angle. 60. Boom. What side was that? BC. Boom. 63 was the largest angle. Go across from it. Boom. AB is the biggest. Same thing on this one now. We look for least to greatest. The smallest side is 5, so we go across. Whatever's across from 5 is going to be the smallest angle. F. 7's the next smallest. D. 8. E. So all you're doing is finding the smallest angle or side and going all the way across from it, and that's also going to be the smallest. And it's a lot easier to see in person, but let's see the random things that I have that might help you see this, like a thermometer and a pair of scissors. So what I'm trying to say is look at the angle between the bottom, right? It's small. Oh my gosh, I can't do this. But if you make that angle bigger on the bottom, right, what's happening to the tip of the scissors and the tip of the thermometer? They're getting farther apart. So the smaller the angle on the bottom, the smaller the side is across from it. And when you make that angle bigger on the bottom, you make that side on top, the distance, bigger. So bigger side, bigger angles. That's really all you gotta know. So that's really the last section. And then we're done. That's all we're doing with triangles this year. So hopefully we'll get that done. I don't have a fever. And then you'll take those last quizzes. And we'll be done. Stop beeping at me. Then you're done with the semester. And we move on October 16, 17, 18, 19th to proportions.